So we got another problem. We have this wooden bracket. Some UHart students have put a bunch of forces on it. And we want to, the dimensions are 3 meters, 1 meter, 1.25, not 1.25 meters. And the forces are 400, 800, 400, and 1200 placed onto here. And we want to replace the applied loads by a single resultant force and specify where on along its line of action it should intersect with the vertical member AB as measured from A right here. So there's going to be some force. Obviously it's going, well, I'm pointing the wrong direction, right? But because I'm flipped over. It's going to go that way, which is pointing towards DX, and it's going to be somewhere and downwards, right? So it's going to be coming this way, downwards right there. And so somewhere we need to like adjust where it's going to be crossing the YAB in order to create that moment for the thing. So let's try to do this one right here, right? So I need a fresh sheet of paper. Here we go. Problem 2. Focus. And focus, focus, focus. See, focus. In focus. You're not going to focus. There you go. All right. Dr. Deal needs to focus. S21, ES110, and this is homework 10. Problem 2. And we will draw our problem out. Oh, I didn't really quite make that horizontal, but it's all right. Okay, so we'll place our forces on here. Force coming right that way, and then we have this dimension here, and here's where this thing is attached to the ground, right here, attached to some bolts, and this is A, this is B, C is right there, and I have D over there, so this is FDY, FDX, FCY, and FBY. Let me see, I'll make a... Oh, that was a terrible line. Well, 100 minutes to mess that up so badly. I must be kind of tired or something. Well, I spent a lot of time today talking and recording. So, kind of burn out. I should go play some guitar. That made me feel better. Should record a song for you in the middle of one of these things. See if anybody actually pays attention to them. XBC and XCD. Here's our given. So, we're going to start with YAB is 3 meters. XBC is equal to 1 meter. XCD is equal to 1.25 meters. The forces FBY 400 newtons. CY 800 newtons. There's a nice face I made, right? Like that. FDY is 400 newtons. and then F dx is 1200 newtons. Okay, so we're going to find equivalent force and location of line of action intersection. This is way too long. Intersection with AB. Okay. That's a lot of words. You should just write the whole thing down exactly as it's stated, right? Otherwise, but all right. So what I'm going to do here, let me find the resultant. That's just the sum of the forces right here. So that's easy enough, right? In the x direction, that's going to be 1200 newtons, obviously. And then here is just going to be 400 plus 800 plus 400. Could have done that in our heads. That should be 1600, right? So here you go. This is going to be 1200 plus 1600 J newtons. But now we want to find what the moment is going to be. So we need to figure out whereabouts on this thing that the moment needs to land. So I'm thinking about this as I'm doing it, trying to think my way through and remember how I'm supposed to proceed. If there's any kind of slick little trick. I don't think so. I could overcomplicate this, but let me see. Let me figure out what the moment about A is going to be. All right, so FBY, it doesn't do anything. FCY, right? So that's going to be, and these are all going to be negative. All right, so this is going to be FCY is the 800, and that's going to be times the XBC, which we see as 1 meter. Exciting. That means FDY, that's also going clockwise, and that's 400, and that's going to be XBC plus XCD, so what is that, 2.25. And then this guy right here, he's also clockwise, and he's 1200, and he's going to be by multiplied by that 3 right there, right? So if we take all of those, I almost used my phone for the phone over here, put the calculator over here, and turn the calculator back on, and you are 800, 400, 2.25 times, all right, so that's plus, and then 1200 times 3, could have done that in my head, and there we go, negative 5,300 Newton meters, right? So now we got to try to figure out where on this thing would we get the 5,300 Newton meters would we need. Now, I would say that it's only the stuff in the x direction, right? So what we would essentially want to do is want to find this location, right? That's going to be something like this right here. It's going to be up and down. I think what we would want to do is that we know that the force is going to be something. It's going to be like something along those lines right there. It's nearly 45, right? It's nearly 45 degrees. It's going to be something along here. I say it's only going to be the x direction that's going to cause this 5,300 right here. So let me see. I'm going to say that my y from A right here, y from A to the force of the thing is going to be this over here divided by the y that's right in there. That's my guess. And then I'm going to go look and see if I could remember, if I'm remembering this correctly. So 5,300 divided by my 1,200. And I just said that wrong. This was the x. Dummy. This was the x. Yeah. Right. So we're going to find that's going to be 4.417 meters. Right there. So that's where that force is going to be taken right there. I'm going to say is we're going to find this resultant is going to be right here, and it's going to be located at, and I didn't do a good job of like trying to dimension this out, like this YAR. I just invented that YAR. So I don't know what to call it. This is where I think this is what I think the answer should be, right? That we say R, the resultant of this thing is going to be 1,200 I, because this Y is going to be straight up and down. It's not going to be doing anything in here. So my wife is returning. I can see that. At Y equals 4.417 above A. So that's my answer. And I'm sticking to it. But maybe I want to look up, and of course I didn't get this out of a book, so I'm not going to be able to find the answer for sure to the thing. But I'm going to. Yeah, I think that's the answer. That's the one we're sticking with. So we're done.